And so now we'll see that the eigenvalues, the eigenspaces corresponding to distinct eigenvalues are essentially disjoint, meaning that the vector space factors as a direct sum. So this is the content of theorem 538. So suppose we have an n-dimensional vector space and an operator on it. If we have a bunch of distinct eigenvalues, so just meaning that they're all different, right? So no repeats. Then when we look at e lambda 1 plus summed up through e lambda n, m rather, this is actually a direct sum. And hence, as a consequence, if we look at the dimension, the sum of the dimensions, it will be less than or equal to n. Okay, so for the proof of this result, so to see that it's direct, suppose that we have u1 plus up through um adding up to 0 with uk in e lambda k. So since the eigenvectors for distinct eigenvalues are linearly independent, that was by proposition 510. This can only happen if all of the UKs are equal to 0. Otherwise, we would have a linear dependence relation, all with coefficients 1, among a bunch of among a linearly independent family of vectors. So then by 1.44, which characterizes direct sums in terms of this uniqueness of representation property, so the only way that you can represent 0 is by the sum of zeros. It's a direct sum. Okay, and since it's a direct sum, we have that the sum of the dimensions of the eigenspaces is equal to the dimension of the direct sum of the eigenspaces, which is less than or equal to the dimension of V, since it's a subspace of V, which is equal to n. And so the reason here for the inequality, and that, by the way, that's the end of the proof. The reason for the inequality rather than the equality there is the difference between the number of distinct eigenvalues and the number of eigenvalues as counted with multiplicity. And so the number of eigenvalues counted with multiplicity could be n, but maybe the number of distinct eigenvalues is m, which is strictly less because there's some repetitions. So this will come up again in the following clips. It'll be sort of like a little technical irritant for us to step over.